Okay, I'll send you. Yeah, I'll send you the link. Okay. Okay.
This meeting is being recorded.
Testing 1 2 testing.
You're echoing. Just letting you know. I don't know if it's me, but
No,
you're echoing, Professor.
it's me. Testing 1 2 testing testing. Oh, you know what? I know what the problem is. Is that the problem? Nope, nope, still echoing. There we go. Unplug. There we go. That fixed it. When in doubt, unplug your speakers. Okay, testing, testing. Hopefully that works. Should be able to. There we go. Okay.
Hello?
Hi, Basti.
Yeah.
Okay, so let's see who's in here.
Okay.
I don't have. Oh, you know what? I may not.
I
have,
don't see Romeo.
Yeah, I think it's because I have to send them. I have to email them the link because obviously if they're not in Canvas, they're not going to get the link. Okay.
Okay, okay.
Let me send them the link as well.
Okay.
Let's-
Do any of you, hi students, do any of you know Vanessa or Romeo, the other Romeo, Romeo Ramos? If you do, just let him know that I'm trying to get a hold of him if you can text him. Let me put my Google number. Hi, everybody. Sorry, you're like, who's this stranger talking to us? My name is Basti. I work at Santa Ana College. I'm the one that's been processing your paperwork and trying to get you all enrolled into your courses. So I'm going to give you all my Google Voice number. If you need to get a hold of me, if you have a question about your course, feel free to text me at that number or call me at that number. If you needed to be enrolled into another section and you only see that you are in math and you had requested another section, let me know. I also want to inform you all that we also have an opportunity for another English section if you are interested in that. So again, get in contact with me that way. And if you do know Vanessa and Romeo Ramos, oh, sorry, Viviana. I keep calling her Vanessa. I'm so sorry. Viviana Diaz Duarte. Yeah, thank you. Feel free to give her my Google Voice number as well as Romeo Ramos.
Yeah, normally the students email me for the link, but they didn't email me today for some reason. There's only 2 left that I don't have enrolled, which is good.
Okay.
Okay, so I just sent them the link. So we'll see if they show up here or not in the next 5 minutes or so.
Okay, that's fine. You can continue your lesson and I'll just put myself on mute. And if they do, I'll just keep checking in the chat.
Okay, that's fine. I can make you co-host, and then you can put yourself into the breakout room that I set up for you.
Sweet. Thank you.
Let me make you co-host here. Okay, perfect. Oh, there's Viviana.
Yay. Okay. I'll work with her then.
Okay, sounds great. Okay, Viviana, go ahead and join the breakout room. Okay, for the rest of us, I'm going to take attendance right now, okay? So let me share my screen. Oh, okay, that's fine. So share screen. Okay, attendance. Going into Canvas. Okay, math 105. Attendance. Okay, so just let me know that you're here when I call your name. Okay, is Cassidy here?
Here.
Okay, Alejandro?
Here.
Okay, Liliana?
Here.
Lainey?
Here.
Cassandra? Okay, Romeo? Diaz. Oh, Romeo Ramos.
Here.
Here, okay. So Romeo Ramos, I'm gonna send
Here.
I'm gonna send you to a breakout room, okay?
All right.
So where is participants? Let me just stop sharing for a second. Okay. Sorry. Okay, so go ahead and just join the breakout room. There you go. Okay, perfect. Go back to sharing the screen. Okay, Brenda Escalera.
Here.
Okay, Jasmine.
Here.
Josue. Okay, Jade Gomez. Valerie Gonzalez.
Here.
Ed Solara.
Here. Hello there.
Hello. Okay, Joel.
Here.
Thank you, Joel. Monique.
Here.
Salvador.
Here.
Caitlin.
Here.
Kayla. Kayla Ocampo. Okay. Paula. I can't say this.
Here.
Thank you. Paola.
Here.
Okay, I got you. I was just trying to say your name. Okay. Alia. Alia. Something like that. Okay. Ricardo
Here.
and Matthias. Is it Matthias here? Matthias Vega? Okay, one more time. Cassandra Diaz. Josue. Jade. Kayla. Aaliyah. And Matthias. Okay. Anybody did not call? Okay. Sounds good. Okay, so our first exam is coming up next week. We're going to finish up material today. Okay. Let's go to our modules here. Okay, so most people have been able to do module 3, which is good. If you haven't been able to finish module 3, or sorry, module 2, please do so. Okay, so I will accept module 3 late for partial credit. Okay, but just up to module 3. Okay, just because once again it's been a rocky start to the semester. Woohoo! Go COVID. Okay, so so again, make sure that you have all of module 2 done up to this point. Okay, make sure you send me you upload the practice worksheet. I was surprised at how many people were actually able to upload this correctly. Thank you so much. Yeah, now this week I graded this based on did you attempt the problems. In 2 weeks, I'm gonna grade it based on accuracy. Okay, so just because you got 20 out of 20 doesn't mean you got them all correct. It just means that you successfully uploaded this and you worked out all the problems to the best of your ability, and that gave you 20 out of 20 points. Okay, so starting with module 5, I'm going to be grading a lot harder on the practice worksheets. Okay, so keep that in mind. Next week is our exam. We have exam 1 review here. That's due before the exam, and then exam 1, which is due on Wednesday. So this is due before the exam, exam 1 review, and then this is due before the end of class on next Wednesday. So 1 week until the exam. We'll be covering a few of the problems on the exam review, the ones that you want help with. Make sure that you attempt exam 1 review this weekend, okay? So that I don't have time to go over all of the questions, but I would like the ones that you found were difficult, okay, and go over those. Okay, today we just have our notes. Make sure you've downloaded the notes and printed those off for today. Okay, we're going to be covering 4.3 and 4.4 today. You only have homework on 4.4 though, but on the practice worksheet for chapter 4, it covers 4.3 as well. So you have this, okay, this is due by Sunday night, 4.4. And so is the practice worksheet. Again, I was very pleased to see how many people uploaded the worksheet correctly into Canvas. Bravo to you. That's why I was very generous with the points this week. If you were successfully able to send that to me, I was like, hey, you deserve the points. So very generous. Next week, I will go over how the exam is going to work. Okay, you'll take the exam. Okay. You take the exam on Canvas. Okay, so just the same way that you do with the homework. Okay, and then you'll be uploading your work. Okay, your work to me as well, and we'll go over all of that next week on Monday. Kind of the exam procedures, how we're going to run through our first exam. Okay. Okay. Well, if you have any questions, please let me know. But again, everybody seems to be doing okay. If you haven't done the practice 1 worksheet or the module 2 here, please get that into me by Friday morning if you can. And let's go through module 3, week 3. We're in week 3, module 3. Okay, so each module goes with the week that we're in, the week number that we're in. Okay. Okay, so let's go through the notes. Oh, was there a question? Okay, I didn't do the assignments that were on Kevin's. I didn't have access. Yes, I understand. And as soon as you gain access, hopefully it'll be within the next couple of days. Then you can go back and do starting with module 2. Okay, you don't have to do anything in module 1. Just start with module 2. Okay. So unfortunately, you're gonna have to do a little bit of catch up, but I definitely want you to do module 2 because that's gonna help you on the exam. Okay. Okay, let me stop my sharing and let's go through today's material. Okay, chapter 4 notes. Okay, we're going to start with section 4.3. Okay, and where do I want to start? And I'm not going to start even at the beginning of 4.3. I'm going to start with 4.3. 4.3.3. Let me check. Yeah, 4.3.3. We're going to start today's notes with 4.3.3. Okay, so it says related and equivalent statements is where we're going to start. Oh, where do I post the lessons? Okay, on YouTube. It's on my YouTube channel. So I do have 2 YouTube channels, however. So you just got to know which one to go to. It's also in the syllabus. So if you go, maybe that's the easiest way for you to get there. Okay, is if you look at the syllabus, it has my YouTube channel on there. Okay, so go to the syllabus here. And we're going to do YouTube channel. Okay. So YouTube channel is right here. Okay. If you miss a lecture, then you can go to my YouTube channel, and there's a link right here. Okay, and it shows math 105. Okay, and then I go to my playlist, and it has math 105. Okay, that's your playlist right here. Okay, and that should have all of the videos. Okay, so here's 1.1 to 1.4, 3.1 to 3.2, 3.3 to 3.4. Okay. Okay. No, it's good. It was a good question because other people are probably going to want to review these for the exam as well. Okay. Go through some of these videos maybe.
The notes that you're going to share in class, are they on Canvas? Because I'm looking for them.
Yeah, they should be.
Oh, okay. Just want to make sure.
I mean, yeah, go to module 3.
Oh, 3. It's not in module 4.
No, because this is week 3.
Oh, okay. Thank you so much.
Yeah, module 3, and it's Lippmann notes for chapter 4.
Okie dokie.
Okay, sounds good. Thanks. Okay. Okay, related and equivalent statements. Okay, some of this you may have covered before when you did geometry. Okay, so some of it should be review possibly. Okay, we have let P and Q be the statements. These are if-then statements. So the implication or the original statement is if P then Q. The converse is if I switch what's called the hypothesis and the conclusion. P is the hypothesis. And Q is the conclusion. Okay, the converse is if I switch the hypothesis and conclusion. The inverse is if I negate the hypothesis and then negate the conclusion. And the contrapositive is that I flip and negate as well. This little line here means negate or not. Okay, so we're gonna, if not P, then not Q, and then if not Q, then not P. Okay, consider the statement, if I win tickets to Coachella, then I will take my friend. What are the converse, inverse, and contrapositive? So let's look at the converse here. So the original statement is if P, then Q. So the converse is going to be if Q, then P. Okay, so that's the converse. So let's see what's the converse going to be. If Q, then P. Okay, the converse. Okay, so I'm going to just reverse the conclusion and the hypothesis. Okay, so maybe if I take my friend to Coachella, then I win tickets. Okay, something like that. Okay, that's the converse. Okay, what about the inverse? The inverse is when I negate, okay, not P and then not Q. So if I don't win tickets to Coachella, if I do not win tickets to Coachella, then I will not take my friend, and I will not take my friend. Okay, so that's the converse. What about the contrapositive? Contrapositive. Okay, contrapositive is if I negate the conclusion and then negate the hypothesis. Okay, so let's negate the conclusion. I will not take my friend. Okay, if I we'll say do not. If I do not take my friend to Coachella, then I did not win tickets. Then I did not win tickets. And sometimes the English is a little hard to navigate with these, but just try to make logical sense. Okay, so if I do not take my friend to Coachella, then I did not win tickets. What was the original statement? If I win tickets, then I will take my friend. The converse, if I take my friend to Coachella, then I win tickets. Maybe I'll say won tickets. Okay. What's the inverse? If I do not win tickets, then I will not take my friend. And the contrapositive, if I do not take my friend, then I did not win tickets. Okay, suppose P and Q are statements. Create a truth table for the converse, inverse, and contrapositive. Okay, so so we're going to have P, Q, okay, and then we're going to have P implies Q. Okay, we're going to have Q implies P, right? The converse, which is Q implies P. We're going to have the inverse, which is not P implies not Q. And we're going to have the contrapositive, which is not Q implies not P. Okay, so this is a truth table. Okay. So we have four different options here. Is if P is true and Q is true. Okay, so this is what's called a biconditional statement. Okay, this is like the statement. If we have something true, true, that's like a definition. That's like saying all right angles, okay, are 90 degrees, right? So if an angle is a right angle, then it's 90 degrees. We could say something like that. Okay. If 90 degrees, then right angle. Okay, then a right angle. If 90 degrees, then right angle. If it's 90, so does it work forwards? Yeah, that's true. Does it work backwards? If something is right, then 90. Yeah, it works backwards as well. Okay, what about the nots? If not 90, then not right. Yep, that's true. And then if not right, then not 90. Yep, that's true as well. So that's all true. If we get two truths, then it's true. Okay, what about if P is true, but Q is false? Okay. Okay, if let's say if I have a 90-degree angle, then acute. Then it's acute. If 90 degrees, then acute. Well, that's obviously false, right? So if 90, then acute. No, they can't be true. So that's a false statement. Okay. Okay. So, well, let's think of it this way. Okay. If P then Q, let's think of it in terms of a Venn diagram. It might be, and we'll say that it's false. I'm going to create one that's false here. True, the if is true, but the hypothesis is true, but the conclusion is false. What would that look like? Let's say that if I own a Honda, okay, if I own a Honda, then it's green. If Honda, then green. Let's try that. If Honda, then green. Okay, so we're saying that, yes, I own a Honda, but it's not green. Okay, I don't own a green car. Okay, so so that's a false statement. Let's go backwards here and see what happens. Okay, see what happens. If green, then Honda. If green, then Honda. Well, if I own a green car, then I own a Honda. That's actually true. Okay. So again, think of it like a Venn diagram here. Okay. These are all the Hondas, and these are all the greens, the green Hondas. Okay, greens. So if I own a Honda, then I own a green car. Not necessarily true, because I could own a blue Honda, right? I could own a blue Honda. But if I own a green car, then I own a Honda. I'm just talking about Hondas here. So that one's going to end up being true. Okay, what about not P implies not Q? If I don't own a Honda, then it's not green. If I don't own a Honda, then it's not green. In this scenario here, if I don't own a Honda, then it's not green. Yeah, we're only talking about green Hondas. So if I don't own a Honda, then it's not green. You could have again this it's kind of a hard it's a hard scenario to try to come up with this truth table for. Let's make it simpler. Maybe I'm making it too hard here. Okay. Let's go like this. Okay, let's just assume that one implies the other. Okay. Let's say I don't like that example. Okay. So if it rains, I take my umbrella. Okay, let's start here. Let's start simple. Okay, it was just getting too convoluted for my taste. Okay, if it rains, I take my umbrella. Okay, if this is a true statement, okay, if it rains, then I take my umbrella. If that's a true statement, then is the reverse also true? Is the reverse also true? If I take my umbrella, then it rains. Is that true? Is it true that if I take my umbrella, it's going to rain? No, it's not true. That me taking the umbrella isn't going to make it rain. Okay, so that's a false statement if I reverse it. Okay, what about the next one here? Okay, what about if it doesn't rain, then I don't take my umbrella. Okay, if it doesn't rain, then I don't take my umbrella. Does that necessarily have to be true? If it doesn't rain, then I don't take my umbrella. Well, can I take my umbrella even if it doesn't rain? Sure.
Yes.
Yeah, so this is false. Okay, if it does not rain, then I do not take my umbrella. I can take my umbrella even if it's not raining. Okay. Okay, what about the contrapositive? If I do not take my umbrella, then it did not rain. If I didn't take my umbrella, then it did not rain. Yeah, because I'm assuming that the original statement is true, right? I'm assuming that the original statement is true. That if it rains, then I always take my umbrella. Okay, so given the contrapositive, if I do not take my umbrella, then it did not rain. Well, that's a true statement. Okay, the original statement, if that one's true, then the contrapositive will always be true. Okay. Okay, the truth table also works if the original statement is false. If the original statement is false, then it's just reversed here. Okay, the converse and the inverse would have to be both true, and the contrapositive and the original statement would both be false. Okay. Okay, two statements that are equivalent if their truth values are the same. It says here, a conditional statement and its contrapositive are equivalent. Okay, so the conditional statement and the contrapositive are equivalent. The converse and inverse are also equivalent. Okay, they mean the same thing. Okay, the truth values there are the same. Okay. Okay. Let's go to arguments. Okay, arguments. Okay, a logical argument is a set of premises that support a conclusion. There are two general types of arguments, inductive and deductive arguments. Okay, a premise is a previous statement or proposition from which another is inferred or follows as a conclusion. It's like, again, it's like if P then Q, that's a premise. If P then Q, one follows from the other. Okay, so we're taking a previous and we're inferring. Okay, now let's talk about inductive versus deductive. Okay, deductive versus inductive. Okay, an inductive argument is a collection of specific examples as its premises to propose a general conclusion. So we're looking at observations to gain say a pattern. Okay. Deductive argument is the collection of general statements to propose a specific situation as the conclusion. So one is more general than the other. Okay. Deductive is specific. Okay, so let's see which is which here. Okay, premise. What type of argument is displayed below? Inductive or deductive? Okay, premise. I forgot my purse last week. I forgot my purse today. Okay, these are observations. Therefore, I always forget my purse. Okay, so this is a general conclusion. And these are observations, past observations. Setting up a general conclusion. So which is this? Deductive or inductive? What do you think? Yeah, it's inductive. Yeah, it's inductive. So it's the first one here. Okay, so this is inductive. Okay, inductive reasoning. Okay. Okay, an inductive argument's conclusion is not proven to be true or false, but it can provide sufficient evidence to support the conclusion. A deductive argument is valid if all premises are true and the conclusion follows logically from those premises. In other words, the premises are true, then the conclusion directly follows. Okay. Now, if we look at the inductive, could the conclusion be false? Could the conclusion be false? I forgot my purse last week. I forgot my purse today. I always forget my purse. Could that conclusion be false? Yeah, it could be. Right? I could have took my purse yesterday, although I don't carry a purse. But I still, if I did, I could have broken the general conclusion by a specific occurrence. Okay. However, let's look at this deductive argument. This one's deductive here. All cats are mammals. Okay. A tiger is a cat. Okay. A tiger is a mammal. Okay. Let's see. Let's use a Venn diagram on this one. All cats are mammals. All tigers are cats. So does it logically follow that a tiger is a mammal? Is this valid or invalid?
Valid.
Yeah, it is valid. It is valid. Okay, it is a valid argument. Okay, because it follows. It follows that if a tiger is a cat and a cat is a mammal, then a tiger is a mammal. So tiger equals cat equals mammal. Then we can, this is called the law of syllogism. You don't need to know that. But then we could say, we could get rid of this intermediary step of cat and go directly from tiger to mammal. I didn't write mammal too well. Okay. So tiger equals mammal. Okay, that's deductive reasoning. When I think of deductive reasoning, I always think of like Sherlock Holmes, because he uses deductive reasoning. He says, look, there's blood on the pipe. There's blood on the pipe. There's a guy with a cracked skull. Therefore, what's the conclusion? Anyone? This is deductive reasoning. Blood on the pipe, guy with cracked skull, pipe, killed guy. Okay, you see how that's deductive reasoning? It's very specific. We're not making a general conclusion here. We're just saying, hey, look, we got blood on the pipe. We got a guy with a cracked skull. Therefore, let's put 2 and 2 together. The pipe killed the guy. Okay, well, someone killed the guy, but with the pipe. Okay, and the conservatory, and it was Miss Scarlet. So, never mind. Okay. Okay, analyzing arguments with Euler circles, it's kind of like a Venn diagram. Okay, step 1, draw Euler circles based on the premises. Draw an X where the second premise lies. If the X is clear where the conclusion lies, then the argument is valid. if the X lies in more than one part of the Euler diagram and it is unclear where the conclusion lies, then the argument is invalid. Okay, so let's draw a circle. No cows are purple. Okay, so this is purple. Okay, this is purple, and so we say no cows are purple. So actually, let's do cows here. Cows, and so we say no cows are purple. So X out here. Okay, no cows are purple. If you're purple, you're not a cow. Okay. Fido. Okay, Fido is not a cow. Okay. Okay, Fido is not a cow. Let's do Fido here. Fido is not a cow. Therefore, Fido is purple. Is that necessarily true? Does that follow from the deductive argument? Well, no, because we don't know that all Fidos are purple. Does that make sense? So this is invalid. This is an invalid deductive argument. Invalid, okay? Invalid. Okay. In general, we can analyze arguments using Euler circles by applying the diagrams below for the premises. Let A and B be the premises of a deductive argument. All A are B. Okay, that's what we'd use for the tigers and the mammals. Some A are B, and not A are B. None of A are in B. Okay, so again, using those, they're calling them Euler circles. They're really just Venn diagrams. Okay. Okay, so let's see if these are logical statements or not. Okay, logical statements. Determine if the deductive argument is valid or invalid. Okay. If I have a shovel, I can dig a hole. If I have a shovel, okay, if I have a shovel, then I can dig a hole. Okay. Okay, if I have a shovel, then I can dig a hole. Okay, if I have a shovel, I can dig a hole. Okay, so shovel implies hole. Yes. Okay, I dug a hole. Therefore, I had a shovel. Is that valid or invalid? Well, I only have one X. Okay, I only have one X, which is good. Okay, I have a shovel, so P implies Q. Okay, I dug a hole. I got the hole, that's true. Therefore, I had a shovel. Yeah, true. Okay, so true. Okay, so yeah, this is a valid statement. Valid statement. Okay, the other way to think about this is this way. Okay, is to say, hey, if I have a shovel, then I can dig a hole. Let's fill a hole here. If I have a shovel, because you can dig a hole with other things other than a shovel, right? So if I have a shovel, then I can dig a hole. You can do other things with a shovel too. You can, like, you know, bat your sister over the head with it. Okay, shovel, and if I have a shovel, I dug a hole. So I dug a hole. Okay, therefore I had a shovel. Well, that one doesn't sit well with me. Okay, this should be a valid statement. Okay, because we're not saying that we could necessarily dig a hole without the shovel. Okay, I mean, I guess you could use your bare hands, but that's not what's implied here. So shovel, and this is the hole. Okay, and so we have this nested inside here. So I'm just saying that it is a valid conclusion. Okay, I dug a hole, therefore I have the shovel. Because they're not telling me any other way that I can dig a hole. They're only saying, look, if I have a shovel, then I can dig a hole. Okay, maybe I can't dig a hole with my bare hands. Maybe I can't dig a hole with anything else. Okay, they only give me one premise on how I can get a hole. Okay. So, you know, maybe I don't have, maybe I have to have a shovel. Maybe it's dirt in Minecraft and that's it. I'm only gonna allow myself to dig a hole with a shovel and not a pickaxe. Okay. So this is a valid argument. That's all I'm saying. Okay, a syllogism is an implication derived from two others, where the consequence of one, okay, is the antecedent to the other. Okay. The general form of the syllogism is, okay, if P then Q, if Q then R, therefore if P then R. And we use this with the whole tiger cat thing. Okay, so that was a syllogism. Okay, this is also called the transitive property. Okay, so let's determine if this is valid or invalid. Okay, if I go to the party, I'll be really tired tomorrow. If I'm really tired tomorrow, I saw my friends. Conclusion. If I did not see my friends, I did not go to the party. Let's see if this is valid or invalid. Okay, so if I go to the party, then I'm tired. If I'm tired, then I saw my friends. Therefore, party implies friends. Okay, the only way I see my friends is go to the party. That's it. No other way. Okay, party implies friends. P implies, we'll call this R. Okay, so what is this saying? If I did not see my friends, if not R, then I did not go to the party, implies not P. Well, this is the contrapositive. And if the original statement is true, then what do we know about the contrapositive? From that truth table earlier, then the contrapositive is also true. Okay, so is this a valid statement? Yes, it's valid. Okay, logically equivalent statement there. Okay, so if I go to the party, I see my friends. If I did not see my friends, I didn't go to the party. Okay. Okay, let's look at this here. Okay, logical fallacies in common language. In the previous discussion, we saw that logical arguments can be invalid on the premises when the premises are not sufficient to guarantee the conclusion, or when there are invalid chains in logic. There are a number of other ways in which arguments can be valid, a sampling of which are given here. Okay, ad hominem. An ad hominem argument attacks the person making the argument, ignoring the argument itself. So that's a personal attack. Okay. Appeal to ignorance. This type of argument assumes something is true because it hasn't been proven false. So we always assume something's true. So, okay. Appeal to authority. These arguments attempt to use authority of a person to prove a claim. While often authority can provide strength to an argument, problems can occur when the person's opinion is not shared by other experts, or when the authority is irrelevant. So just because Shaq likes the Nike sneakers doesn't necessarily mean they're the best. Okay, appeal to consequence. An appeal to consequence concludes that a premise is true or false based on whether the consequences are desirable or not. Okay, so, you know, based on the outcomes. Okay. False dilemma. A false dilemma argument falsely frames the argument as an either or choice, okay, without allowing for additional options. Okay, either this or that. Well, could not be either. Okay, that's called confounding variables. There are confounding variables. Confounding. Let me write it better. Okay, confounding variables. Circular reasoning. Circular reasoning is an argument that relies on conclusion being true for the premise to be true. Okay, circular reasoning. Straw man. A straw man argument involves misrepresenting the argument in a less favorable way to make it easier to attack. Post hoc argument claims that because two things happen sequentially, then the first must have caused the second. And this is a big thing you need to know, is correlation does not imply causation. Okay? Okay, so more people go to the beach and more people eat ice cream. Right? Does that mean that because people are going to the beach, more people are eating ice cream? No, it means that there's a third, they're correlated, sure, but is one causing the other? No, what could be causing both of them? How about it's hot out? Does that make sense? Okay, so correlation does not imply causation. Just because two things are correlated doesn't mean that one's causing the other. That's a big, okay. Okay, similar to post hoc, but without requirement of sequence, this fallacy assumes correlation implies causation. Fallacy assumes that just because two things are related, one must have caused the other. Often there is a third variable not considered. Okay, identify the logical fallacy of the arguments here. Identify the logical fallacy of the argument. Okay, if we can. Only an untrustworthy person would run for office. The fact that politicians are untrustworthy is proof of this. I'm going to go with circular reasoning on that one. Circular reasoning. Okay, because it's saying that you have to be untrustworthy to run for office, because only an untrustworthy person would run for office. That's just kind of going around in a circle. So circular reasoning on that one. Since the 1950s, both the atmospheric carbon dioxide levels and obesity levels have sharply increased. Hence, atmospheric carbon dioxide causes obesity. Okay, what's the fallacy here? We just talked about it. Okay, it's the last one. Correlation implies causation? No. Okay, correlation does not imply causation. Okay, the oven was working fine until you started it, so you must have broken it. You can see like maybe your mom saying that. Like the oven was working fine until you started it, so you must have broken it. Okay, what's that one? Two things happen sequentially, then the first must have caused the second. Two things happened one after the other, therefore the first must, no, that's a fallacy. That's post hoc. Post hoc. Okay. You can't give me a D in this class. I can't afford to retake it. Yeah, I can give you a D, even if you can't afford to retake it. Okay, this is what we call an appeal to consequence. Okay, the appeal to consequence concludes that a premise is true or false based on the consequences are desirable or not. Okay, no, your consequences are non-desirable. Therefore, I'm still going to give you the non-desirable what was that? Appeal to consequence. Yeah. The premise. It's a non-desirable premise. Okay. So this is appeal to consequence. You can't give me a desirable action because there's, or an indesirable action because there's an indesirable reaction. No, that's not true. Okay, the senator wants to increase support for food stamps. He wants to take taxpayers' hard-earned money and give it to lazy people. This isn't fair, so we shouldn't do it. Okay, so this was kind of hard to see. This is a straw man. It says, the straw man argument involves misrepresenting the argument in a less favorable way to make it easier to attack. So we're saying that he wants to take taxpayers' hard-earned money and give it to lazy people. So we're making the actions of the senator less desirable in people's minds. Therefore, the conclusion is it shouldn't be done. So that is called a straw man argument. Okay. Okay, and that's all of chapter 4 that we'll be covering in the notes today. Let's go over some of the homework real quick. Okay, let's see. Yeah, let's look at that. Okay. So if you want to pull up your homework, you can at this point. Let's see what's in store for us in Module 3. Okay, Module 3. Okay, so it says practice inductive and deductive reasoning. Okay, let's see what's going on here. Zoom. Okay, so let's look at question 1. Decide whether inductive or deductive reasoning is used to reach the conclusion. The rule at your school is that you must attend all your classes in order to participate in sports after school. You played in a soccer game after school on Monday. Therefore, you went to all of your classes on Monday. Okay. That seems very specific to me. One implies the other. So I'm gonna go with deductive on this. Would you agree? Agree? That would be deductive. Okay, so it says the rule is that you must attend all classes in order to go to sport. You played soccer, therefore you went to all. I'm gonna go with deductive on that. Let's see. Good. Good. Submit. Boom. Correct. Nice. Okay, number 2. Okay, decide whether inductive or deductive reasoning is used to reach the conclusion. For the past 5 years, your neighbor goes on vacation every July 4th and asks you to feed her hamster. You conclude that you'll be asked to feed her hamster on the next July 4th. Is this inductive or deductive? So it's kind of hard to see, but generally deductive is a premise based on is premise based on past events that you can conclude are happening now, like in the present. Inductive is more like a conjecture about what's happening in the future. So I'm gonna go with inductive on that one because I think it's a conjecture about what's going to happen in the future. Okay, deductive is like the blood is on the pipe, therefore, and the guy is dead, therefore he was probably killed with the pipe. That's putting a conclusion together about what happened in the past. We're not making a conjecture about anything in the future. We're not saying that only people are going to get killed with pipes. Okay, but a inductive is really looking at a pattern and thinking about, well, what's the next one? That's inductive. If you think like, if I start off going 1, 2, 3, what do you think is going to be the next number? Four, right? 1, 2, 3, 4, right? That's called inductive reasoning. You're looking at a pattern and you're thinking about what's going to happen next. Okay, what's happened next? Deductive is more, let's do a conclusion about what already occurred. Okay, so let's see that one. Ooh, nice, inductive reasoning. Okay, next page. Next page. Is this a valid or invalid? Let's see. Let's go. Oh, question 3. Premise 1. The defendant has no alibi for the night of the theft. Okay. Premise 2. The stolen goods were found in the defendant's possession. Premise 3. 2 witnesses have identified the defendant as the thief. Conclusion, the defendant is guilty of theft. Decide whether the argument is inductive or deductive. Is it inductive or deductive? Well, again, we're making a conclusion based on, past events. And we're only concerned about those past events, not what's happening in the future. I'm going to go on with deductive on that one. Okay. Yeah, thank you. Thank you, Romeo. Okay, I'm going to go with deductive on that one. If the argument of if the above argument is inductive, okay, decide if it is strong or weak. Select not applicable if the inductive. Well, I'm going to go not applicable. It was not inductive. If the argument is deductive, decide if it is valid or invalid. I'm going to go valid on that one. I'm going to say this dude's guilty. Valid. Submit the question. No. Ooh, I got them all wrong. How did I get them all wrong? Last. What? I got them all wrong. Oh, is it because I'm making a general statement? Maybe it's because I'm making a general statement. Let's see what we got here. Inductive. I'd say it's a weak. Is it a weak argument? Maybe they're all wrong. Not applicable. Let's see. Nope, it's a strong argument. Okay. Good to know. Good to know. Good to know. Okay. Interesting. Okay, let's try the next one here. Okay. Determine if the conclusion follows logically from the premises. Premise. If an animal is a rodent, then it is a mammal. Premise, rats are rodents, therefore rats are mammals. Well, we already saw this one. This is a valid argument. Okay, valid. Okay. Next page. Okay, determine if the following argument is inductive or deductive. The last mayor was honest. The current mayor is honest. Therefore, all mayors are honest. I would say that's inductive because we're making a general statement. We're generalizing this. That's a general statement. Yeah, that's good. Okay, now, question 6. Determine if the following argument is inductive or deductive. The sun rose yesterday. It has risen every day of my life. Therefore, the sun rises every day. I'm going to go with deductive on that one. Nope, it's inductive. Okay, I guess it's because it's a general statement. We're generalizing it to every day. Okay, inductive. Okay, determine whether the following argument is inductive or deductive. Every word has the letter E in it. Okay. Therefore, your name has the letter E in it. Well, if every word has the letter E in it, then yes, your name would have the letter E in it. I'm going to say deductive. Good. Okay. Deductive. Logical conclusion. Does it logically follow? Determine whether the following argument is inductive or deductive. All deserts have some plant life. Some plants must therefore live in the Gobi Desert. Deductive, or I'm making a conjecture about what lives in the Gobi Desert. Ooh, this one's hard. All deserts have some plant life. Some plants must therefore live in the Gobi Desert. All deserts have plant life. I'm going to go with deductive on this one. I may be wrong. Nope, it's good because we're just making a conclusion. Okay, think of the Venn diagram on that one. It's deserts would be the big circle. Gobi Desert would be the small one. Okay, let's look at question 9 here.
Mr. Holman, for question 9, all the answers are mixed up for the question. It's not like the right answers for some of the questions.
Oh, okay. Well, maybe I'll see if I can get rid of that question. Let's see. Decide whether the above argument is inductive or deductive. For me, it comes out, okay, so for question number 9, right?
Yeah, the other question.
Oh, the other ones, okay. Let's see. All islands are tropical. Iceland is an island. Therefore, Iceland is tropical. Okay, so again, I would go with deductive on this one, I think. Okay. If all islands are tropical and Iceland is island, then yeah, Iceland is tropical. Okay, if the above argument is inductive, cited is strong, I'm going to say it's, oh yeah, you're right. They're reversed. The deductive, yeah. Yeah, this is, yeah, I'm going to have to get rid of this one. What did they say was the answer? Valid? Yeah. Strong? Nope. Weak? Nope. Not applicable. Nope. Sound? Nope. Unsound. Yeah, I don't know. I'll get rid of number 9. Okay. At least you know what or you can just plug in, write down the answers to that one. Okay, then I won't have to get rid of it. Yeah. So I don't make up these problems on my own. They come from an open library, so sometimes there are errors. Okay, determine if the conclusion follows logically from the premises. Premise, if it has an engine, I can fix it. Cars have engine, then I can fix cars. I'm going to say that's a valid argument. Yes. Okay, determine whether the following deductive argument is valid or invalid by choosing the correct type of Venn diagram. All dwarfs planets have mass less than 100 times the mass of Earth. The mass of Ceres is less than 100th times the mass of Earth. Therefore, Ceres is a dwarf planet. Let A be the set of dwarf planets. Okay. Let B be the set of planets. Okay, that have mass less than 100 times that mass of Earth. Okay, let X be the planet Ceres. Okay. If X is shown on the border of a set, it means that it cannot be determined whether it cannot be determined. Okay, so which Venn diagram can be used to demonstrate the above information? Well, I'm going to say that Ceres is both a dwarf planet and a planet that has, let's see, all dwarf planets have mass less than 100 times the mass of Earth. So I'm going to say that B is the planets. Yeah, B is the planets that have left. Yep. I'm going to go with B on this one. Let's see if I'm right. I'm going to go with B. Okay, is this argument valid or invalid? I would say it's valid. What did I get on this one? Nope, it's not B. Interesting. What do they say? Is it on the border? See what they say. It is. I think it's invalid. Oops. Share screen. Yeah, they're saying that it's C and that it's invalid. They're saying it's C because it's right on, it cannot be determined, it's right on the edge. The mass of Ceres is less than, oh, okay. Less than 100, therefore Ceres, right, okay, I see what they're doing here. Okay, so if we think about this, okay, so here's all the planets that are less than 1/100th of Earth, and then all dwarf planets are that, right? So we don't know that whether or not it's a dwarf planet. All we know is that it's in there. Okay, so they're saying that it cannot be determined. Okay, it just fits one of the criteria. It doesn't fit both. If it told me that Ceres was a dwarf planet, then it would fit both criteria and then it would be valid. Okay. So why it's not A, I have no idea. Why is it C and not A? Okay. If X is shown on the border of a set, it means that it cannot be determined whether X is in the set. What was X? Let X be the planet Ceres. I don't know, that one's confusing. Okay, determine whether the deductive argument is valid or invalid by choosing the correct type of Venn diagram. Every region with pyramid structures was home to an ancient civilization. Okay, so pyramid structure, ancient civilization. Okay, so let's do the Venn diagram again. Okay, Venn diagram here. Okay, so everyone that had pyramids was part of an ancient civilization. So not all ancient civilizations had pyramids, but if they had pyramids, okay, if they had the pyramids, then they're part of an ancient civilization. Okay, I can go with that. That's logical. Let's keep going. Cydronia is a region of Mars with pyramid structures. Okay, so Cydronia had pyramid structures. Okay, so Cydronia had pyramid structures, therefore it is ancient. Yes, I can go with that. Okay, therefore it was home to an ancient civilization. Conclusion. Okay, which Venn diagram? I believe this is going to be D, the one where it's yes, yes. Is this a valid argument? I'm going to say it's valid. Submit. Yes. Nice. Both are correct. Okay, question 13. Defendant has no alibi for the night of the theft. Okay, the stolen goods were found in the defendant's possession. 2 witnesses. The defendant is guilty. Decide whether, can we do this one already? Decide whether above argument is inductive or deductive. Okay, 2 witnesses identified stolen goods. The defendant is guilty. I would say that's a gross generalization. I'm going to go inductive on that one. If the above argument is inductive, is it strong or weak? I'm going to go strong. Okay, if it was deductive, I'm going to go invalid. No, not applicable. And the other is if it is and if it is sounder, I'm going to go with sound. Submit question. Oh, it was sound. Sorry. Nope, it wasn't. Not applicable. So, okay. So this one, we've got inductive, strong, not applicable, and not applicable. Okay. Sounds good. Because it wasn't deductive, it was inductive. Okay, question 14. I signed my kids up for swimming lessons this summer. We are staying in our hometown this summer. The only pool in our hometown is the Washington pool. Conclusion, the swimming lessons are at the Washington pool. Okay, let's see what's happening here. Okay, I signed my kids up for swimming lessons. Okay, that's good. The only pool there, we are staying in our hometown. Okay, they're in their hometown. The only pool in our hometown is Washington pool. Okay, so this one, yeah, I would go with that. I would say that that's deductive because there's no other alternative here. If there's no other alternative, then I'm going to go with deductive on that one. If it is inductive, decide if it is strong or weak. It's not applicable. Okay. I'm going to go that it's a valid and then it's sound. Oh, I got it all wrong. Is it inductive again? Ah, inductive. Okay. I don't know why it was inductive. I don't like this. If the above argument is inductive, decide if it is strong or weak. Okay, I would say that it's strong then. It's a strong, not applicable, not applicable. Let's try that one. Yep, that was it. It was a strong inductive. I still don't understand why that would be inductive because there's no other conclusion that you can make there. You're not generalizing anything. So whatever. That's why I'm going over these with you guys because some of them are counterintuitive. Okay, premise 1, all cups in my house are green. I'm drinking from a green cup. I must be home. No, that is not valid. That is not valid. If it said I am home, if you switch the premise and the conclusion, then that would be valid. But I don't think this is valid. Okay, all cups in my house are green. I'm drinking from a green cup, therefore I must be home. Now, is it deductive or inductive? Let's go back to the definition of deductive and inductive for this one. What the heck is it? Let's go back to the book's definition. Where's my tree? Oh, here we go. Inductive argument is a collection of specific examples and uses its premises to propose a general conclusion. Okay, a deductive argument is a collection of general statements as its premises to do a specific. Oh, it's the premises are specific and the conclusion is general. For inductive, the premises are specific, the conclusion is general. Or the statements are general and the conclusion is specific. Okay. I'm going to say that this is a specific conclusion. So I'm going to go with deductive on that. It's saying, hey, you must be home. That's specific. That's pretty specific of a conclusion. If the argument above is inductive, I'm not going to say it's not applicable. If it's valid, I would say that it's an invalid, that it is invalid, okay, and that it is unsound. Nope, still got it all wrong. That's great. Inductive. Okay, so if it is inductive, and it's making a general conclusion, then this is invalid, right? If it's inductive, oh no, is it strong or weak? Okay. I'll say it's weak, and then not applicable and not applicable. Let's see, there we go. It's a very weak argument. Okay. Okay. And this one is the exact same one. Is it not? Not the exact, it's the freaking exact same one. Okay. Great. I'm going to get rid of question 16. So number 9, I'm going to get rid of, I'm going to get rid of number 16 if I can. Because this is just a duplicate. So this is inductive, not applicable. No. Decide whether it is inductive or weak. Is weak. What the heck? They switch these things. So this doesn't even make any sense. Question 16. I'm getting rid of question 16. Okay, choose the words that makes the final statement true. Devenante roots for all the local sports teams. The Bobcats are local sports, so Devenante must root for the Bobcats. Boom, yes. Oh, I like these. Select the words that make the conclusion true. Seminole, Masa Verde Park is in Colorado. Seminole vacation, so Seminole may have visited. Let's do may have. There we go. May have. It's very weak conclusion. Okay, use the following statements below to determine whether or not the conclusion is true or false. If Arlo goes to the baseball game, then he will buy a hot dog. The baseball game is not sold out. Arlo and Mia will go home. Or sorry, we'll go to the game. If Mia goes to the game, she will buy popcorn. The baseball game is not sold out. Okay, so if it's not sold out, then they went to the game. And therefore, they're eating hot dogs and popcorn. Okay, so Arlo bought a hot dog. True. Arlo and Mia went to the game. I think that's supposed to say went to the game. It's true. Mia bought a hot dog. False. Arlo had some of Mia. False. Okay, there we go. Got that one right. Boom. Done. Okay, so we just did your homework for you. Okay, and hopefully you were following along. Did anybody follow along and get all their homework done for this module?
Yep.
Yep. That would be the smart thing to do. Okay. So you'll have, good. So you have the worksheet due Sunday night by 9 o'clock. Okay, so make sure you submit that on Canvas. And yes, for those 2 students who are not enrolled yet, you can email that to me as well. And then we will make sure that you look at the review for module 4, okay, before Monday. Okay, go through the review this weekend. So that's your weekend homework. Okay. Can I go over number 6 from yesterday's homework? Sure. I'm not going to require people to stick around for that, but I will go through that real quick for Romeo. Okay, so I will see you guys on Monday. Okay.
Bye. Thank you.
Yeah, you're welcome. Okay, so Number 6 on yesterday's homework, is that what you're saying?
Yeah,
Oh, on the worksheet? Is that what you're asking for?
yeah, on the worksheet, the Venn diagram.
Sure. Bye.
It was asking to write an expression for it.
Oh, okay. Yeah, let's go through that. Come on, stop. Okay, so number 6, you said?
Yeah.
Write an expression for the shaded region. Okay. So for this one, okay, I want A and C. Okay, I want C to be included. I want all of C to be included. Okay. But I don't want the overlap between A and B. Okay, so I want A and C. So I want the union. Let's see. I want why is it wanting to open it like that? Okay. So let's go here. So we have A, B, and C, right? Okay. And
I can't see the.
oh, is that better?
Yeah.
Good. Okay, and we want this piece here. Right? Okay, so what I want is I want all of C. I want C. Okay, I want all of C. Okay, unioned. Okay, unioned with none of B. Okay, I want everything that's not in B or B complement. Okay. Okay, and then let me think about this. Let's do A. No, because B complement would be that. That's the union. I want the intersection. Let's see. What we got here. Okay, so C and then the intersection of. I don't want this piece. So I want to exclude this guy here is what I really want to exclude, and this here. Okay, so I don't want, I want all of C. Oh, here we go. Okay, I need parentheses. I want all of C, but I don't want, I only want A intersection, union with B complement. I want all of B, I want all of A, no, do I want the intersection? Yeah, I want the intersection. Okay. I want all of A that's not in B. I want all of A that's not in B and then union with C because I want all of C. Okay.
Actually, no, never mind. And that's how you do like that problem.
Mhm. Yeah.
Would there be more like that on the test or quiz?
I have to look at the test. I don't know.
All right, thank you. On the homework, I put like minus something, but it was wrong.
Um,
All right, thank you, Professor.
I'm scared. Opening yourself up to the demonic.